Hello everyone. In our last video, we understood the concept of US, that is ultrasound sensor, and we wrote one function module to read the value of ultrasound sensor. The distance was equal to duration divided by 58.82. It was mentioned in earlier video 58.2, but it is 58.82. Now we are going to write program for obstacle avoider. Now, what does obstacle avoider do? Whenever our vehicle is moving and it encounters an obstacle, the vehicle changes its path. How will it know the obstacle? We will use ultrasound sensor. It will continuously read the distance between the vehicle and the obstacle. If the distance between the vehicle and the obstacle is greater than 12 centimeters, we will not take any action. We will continue moving on. The moment the distance between the vehicle and the obstacle becomes less than 12 centimeters, we will take a turn. We will avoid the obstacle. That is our task at hand. So for that, since we need a vehicle, we will include the vehicle library. That is Fire motor. We'll create the instance. I'll name it as V. Also, we need to read this value of ultrasound sensor. That means we need to store it somewhere. And for that, we will create a variable dist. And that variable has to be of type float because the value which we are going to get is of type float. And now we are ready with all our prerequisites and we can start writing the program. Now we know when we write a sensor program, what we do? We do RSCA, read, store, compare, act. So let's read the value. How do we read the value? We use this function module which we have created. US sensor value in bracket. Now I need to pass these two parameters, the trick pin and the echo pin. In my Fire shield, we have two places where we can attach ultrasound sensor, US sensor 1 and US sensor 2. US sensor 1 uses pins A2 and A3 and US sensor 2 uses pins A4 and A5. We will use US sensor 1, which means we'll use pins A2 and A3. A2 is our trick pin and A3 is our echo pin. So here A2, A3. This command is going to read the value and this we need to store. We need to store it in variable dist. And so it will be dist equal to whatever value is read by this function module. So here what will happen is when we execute this command actually is called as call to function. So this calls to this function. While calling, this puts this value A2 into variable trick, A3 into variable echo, and then performs this action. Digital write trick. Trick is A2 now. A2 low. Digital write A2 high. And at the end, it returns the distance. And this distance is now will be stored in our variable dist. And that is the whole task of this command. So this is a call to function. It calls the function performs the action and comes back here. And now we go to the next line of command. We have already read the distance. We have stored it. RS is done. So now it is time to C, which is compare. Compare, we need if distance. If distance is greater than 12 centimeters, which is dist is greater than 12, The action is keep moving. So go forward. V dot forward. So I'm going to use speed 200. V dot forward. So that is action when distance is greater than 12. Now, what if distance is not greater than 12? That is else. It should turn. V dot hard right turn. So whenever distance is less than 12, the vehicle will turn. Now we have given this distance as 12. You can try the program and then you can adjust the distance. You can decide at what distance you want to turn. Sometimes this distance may not be sufficient for it to turn. In that case, increase the distance. If you think that your robot is turning quite fast, then you can reduce the distance. You can go further close and then only turn. So you can adjust this distance. So this is a very simple ultrasound program for obstacle avoidance. It checks distance between the obstacle and vehicle. If it is greater than 12, keeps on moving. Else, that means it is less than 12, it takes a turn. Now we haven't given any delay because delay is a brain dead condition. Your robot stops thinking when there is a delay. So in sensor programs, we generally do not use delays unless until we have a specific requirement. Now, how much it will turn? It will keep on turning till it sees the obstacle. Does not mean that right turn means it is going to turn 90 degree. No, it is going to turn a little bit every time. And this thing is written in loop, so it will be continuously executed. From my experience, I'll tell you one more thing. Our ultrasound sensor, which is SR04 sensor, has range of 25 centimeters, which means beyond 25 centimeters, it will not give reliable values. And what happens is many times if the distance is more than 25 centimeters, it gives wrong values. It gives values between 0 to 0.5. So even if the distance is maybe 50 centimeter, it will show you the distance as 0.3, 0.02, 0.09. And your robot will think that there is an obstacle so close and it will try to turn. We don't want that to happen. So what we are going to do is here we are going to modify our condition and we are going to say that distance greater than 12 or distance less than 0.5. Even if distance is shown as less than 0.5, still keep on going because we know that it shows between 0 to 0.5 when the distance is actually greater than 25 centimeter. Distance greater than 12 or distance less than 0.5 centimeter, keep on going forward. These two lines here, parallel lines, indicate OR. So this or this, if any of these condition is true, move forward. So this is the program for object avoider using ultrasound sensor.